Okay, so I'm going to start off with 2015 question 6 part E. Okay, so we're told ethanol can also be used as a fuel. Calculate the heat of formation of ethanol, given that the heat of combustion of ethanol is that, and that the heats of formation of carbon dioxide and water that. So firstly, we're asked for our heat of formation of ethanol. So this is what we're asked for, our ethanol formation. So I'm looking for that. Okay, so ethanol is formed, so it's on the right hand side of my equation. I need two C's in total. I have H, okay, and I have 6 of them. And hydrogen always exists as a H2, so it's 3H2 plus, and again oxygen, I've only 1, so it has to be a half O2. So that's what the overall equation is, is what I'm looking for. And I'm told that the heat of combustion of ethanol, so a heat of combustion reaction is when it reacts with carbon dioxide and it produces, when it reacts with oxygen and produces always carbon dioxide and water. And my delta H of reaction for that is minus 370.7. Okay, this is what makes this particularly hard, because you actually have to balance this. So if I look here on my left hand side, I have 2 carbons. So I have to have 2 carbons over here on my right hand side. If I look then, I have in total here 6 hydrogens. So I need to have 6 over here. So 3 by 2 will give me 6. Then if I look at what I have here, I have 4 carbons and I have 3 oxygens. So in total I have 7 oxygens on this side. 1 oxygen is here, so I need another 6, so 3O2. Okay, so coming up with the equation here and balancing it is the hardest part. You do need to know that, okay, heat of combustion reaction with oxygen always produces carbon dioxide and water. And then the others are fairly straightforward. You're told the heats of formation of carbon dioxide and of water are minus 393.5 and minus 285.8 respectively. So to make carbon, I react carbon and oxygen, and remember oxygen O2, and again to react water, hydrogen H2, but I've only 1 oxygen, so it's a half O2. Okay, and what we do now is we look at what I have up here, and we're going to make sure that what I have here corresponds with here. So first thing here is if I look at my ethanol, it's on my left hand side here, and I need it on my right hand side here. So the first thing I need to do is reverse. So I have 2CO2 plus 3H2O, and that goes to C2H5OH plus 3O2. And remember, when I reverse, I change the sign. So it's going to be plus 1370.7. Next here then, I am looking at the second equation, okay, and I have a C here, but I have 2 C's up here, so I have to multiply this by 2. Okay, so 2C plus 2O2 goes to 2CO2. And I also have to multiply my value of minus 393.5. And I have to multiply that also by 2, which gives me minus 787. After that then, I have H2 plus a half O2 gives me H2O. If I look up here, I have 3 H's, so I need to have 3 H's here. Okay, so I have 3H2 plus 3 over 2 O2 goes to 3H2O. And again, I have to multiply this value by 3 as well. So minus 285.8 gives me a minus 857.4. And what we do now is we compare what we have on our left hand side and right hand side, and anything that's on both sides can cancel. So 2CO2 cancels with 2CO2. Okay, now if I look at this, 3 over 2 is the same as 1.5 O2. Okay, so I can cancel 2 of the O2s and 1 of the O2s with 3 O2. Okay, 2 and 1 gives me 3, so I'm left with a half. And the 3H2O cancels with the 3H2O. And at the end here, 2C plus 3H2 plus a half O2 gives C2H5OH. And if we look at what we have up here, that is exactly what I am looking for. So I'm going good so far. So I then add up all the numbers here. Okay, so plus 137.7. Plus 1370.7 minus 787 minus 857.4, and that gives me a delta H value of minus 273.7. Okay, and always that's measured in kilojoules per mole.